My name is Laurie Bayet. I'm a postdoc at the University of Rochester and Boston Children's Hospital, working on developmental cognitive neuroscience.
My name is Alon, and I am studying currently at Oxford. I'm doing my PhD there with Professor Tim Behrens, and I'm currently working on computational cognitive neuroscience.
Alon and I are trying to use a paper by Tommaso Poggio and co-authors on a specific way to achieve invariant recognition in computer vision or other algorithm. So we're basically trying to implement this in a simpler case, and then moving on to face recognition under rotations.
The idea is that most of the variance in computer vision, when an algorithm tries to discover what is in the image, is held in very few manipulation, like translation, which is just shifting the image across the field, or rotations, or scaling. Tommy Poggio has a cool idea of how to create this signature that Laurie just told about, which is invariant to these things, and might reduce the sample complexity, so how many examples you need to learn.
For the simple case, we just used an existing data set of digits. For the face data set, we tried to find a suitable data set online, but we ended up just taking videos of people using materials provided by the summer school, so taking videos of people rotating their heads like this slowly.
Yeah, it was fun.
Or moving around a little bit.
We have now a complete data set of the heads of people from different angles.
We want to provide the algorithm with a hopefully limited number of raw frames from people rotating their heads like this. Those templates, so to speak, can act then as like a kernel, so to speak, to be able then to recognize unseen people under various angles, so that whatever a person is showing this profile or this profile, you would still be able to recognize it with the same level of accuracy as if they were presenting a frontal face.
The purpose of doing this project would be, like in the long run, or what this I theory, as Tommy Poggio calls it, will be in the long run, would be to reduce the number of examples that an algorithm, for example, deep neural nets, the number of examples they need to see in order to learn their weights, in order to learn how to classify objects or retrieve, how to classify images or retrieve images.
We haven't started the face part, we only started the digits part, which worked, so yeah.
It's working basically. We hope it will also work in the endlessly more complex domain of faces, but we're reasonably optimistic. I don't know, we'll see. Fingers crossed.
We've approached the project from pretty much very different angles, but still ended up having common interests, which I guess is kind of the hallmark of this summer school too. Like Alon has decided we're interested in the engineering problem, so to speak. So like, how can we achieve this with machines? And I approached the project from a developmental perspective. So given that the current algorithms manage to do invariant face recognition based on a fairly large number of exemplars, how come that infants can achieve this in a few months based on a lot of experience, but not that much, mostly looking at their parents, caregivers, and a few other exemplars, but not like 3,000 people from all possible angles. So this is why I was very interested in this theory, and trying to implement this manually has been pretty cool so far.